Surprise. Anyway, please give your full attention to AlexRittle, our next 3MT competitor.
Rivers are a majestic yet ubiquitous component of our natural landscape. They provide some of the most essential components to our everyday life. However, scientists struggle with the ability to map rivers continuously and in their entirety at small enough spatial scales for us to understand small-scale changes. Somebody move the next slide. The background of this slide is a satellite image of a local river and showcases the traditional means that scientists use to extract information about a river. And while such satellite data provides useful planimetric detail, it's very difficult to understand how deep the water is or characteristics of the substrate. Therefore, the central crux of my dissertation lies in this one fundamental question. How do we map the river in its entirety in 3 dimensions? The answer to this question lies in the use of small, remotely controlled aircraft, or drones. Using these drones, we can take aerial photographs and develop 3-dimensional models on centimeter-level scales. To do so, we stitch the overlapping photos together, and we condense these photos to a series of points. These points are then projected onto a 3-dimensional scale space and formed what's known as a point cloud, which you see on the lower left hand of this slide. This point cloud is then refined to create the 3-dimensional model that you see on the right. And what's striking about this is that you can see individual rocks and pebbles. You can see the relief along the channel banks. This was not before possible using the satellite image. If you look at the graph on the top right, I've plotted water depth as a function of distance along the channel. The red line you see is ground truth data. This is data I collected in the field. And the blue line is the depth extracted from the 3D model alone. And this information is striking. This means that we can develop water depth maps continuously along the channel with greater accuracy and precision than ever before. And this really excites river scientists. This means that they can look at small-scale changes in sediment flux that they couldn't before. This can be used to aid in river, in the biology of the river and fish habitat. It can be used for aiding in understanding the flooding of the river, and it can be used in dam removal projects. So I ask you, the next time you see a little plane flying high in the sky, be sure to give it a wave hello. Thank you very much.